Today on Astronomy Daily, we have an action-packed episode filled with big developments from across the cosmos. We'll start with the successful launch of NASA's SpaceX Crew 10 mission, which is now carrying 4 new crew members to the International Space Station. We'll also explore NASA's groundbreaking EASY mission that's set to study the mysterious electrical currents flowing around Earth's poles. Then, we'll venture into deep space to examine a cosmic mystery that's baffling astronomers. A shape-shifting Blazar that's breaking all the rules we thought we knew about these powerful objects. From there, we'll check in on China's Tiangong Space Station and their busy schedule of experiments and future missions. And finally, we'll look at how Earth's newest astronomical eye, the Vera Rubin Observatory, might help guide NASA's New Horizons spacecraft to new discoveries in the distant Kuiper Belt. So, let's get started with the news we've all been waiting to hear. In a spectacular nighttime launch from NASA's Kennedy Space Center in Florida, SpaceX's Falcon 9 rocket successfully lifted off at 7:03 p.m. EDT on Friday, carrying the Crew 10 mission toward the International Space Station. The Dragon spacecraft carried an international quartet of space travelers, NASA astronauts McClane and Ayers, JAXA astronaut Takuya Onishi, and Roscosmos cosmonaut Kirill Peskov. For Commander McClane, this marks her second journey to the orbital outpost, while mission pilot Ayers is embarking on her first space flight. Takuya Onishi is making his second trip to the station, and Kirill Peskov is experiencing his first venture into space. The Dragon spacecraft is scheduled to dock autonomously with the station's Harmony module, where the new arrivals will temporarily bring the station's crew complement to 11. This highlights the increasingly busy nature of our orbital outpost and the growing international cooperation in space exploration. During their stay aboard the station, the Crew 10 team will conduct numerous scientific investigations, including material flammability tests that will help inform future spacecraft design. They'll also engage with students worldwide through the ISS Ham Radio program and participate in physiological studies that will provide crucial data for future deep space missions. This mission represents the 10th crew rotation under NASA's Commercial Crew Program, demonstrating the success of the agency's partnership with private industry. As acting NASA Administrator Janet Petro noted, these missions are laying the groundwork for future exploration, from low Earth orbit to the Moon and eventually Mars. The successful launch of Crew 10 continues the remarkable achievement of maintaining a continuous human presence in space, with the International Space Station now having been continuously occupied for more than 24 years. This mission not only advances our scientific understanding, but also strengthens the international bonds that make space exploration possible. It also means that Butch and Suni can finally come home, and we should see them back on Earth shortly. NASA's newest mission to study Earth's auroras is preparing for launch, with 3 small but mighty spacecraft ready to unlock the mysteries of the spectacular light shows we know as the Northern and Southern Lights. The Electrojet Zeeman Imaging Explorer, or EASY for short, represents the first dedicated mission to study auroral electrojets, powerful electrical currents flowing high in our planet's atmosphere near the poles. These remarkable currents can push up to 1 million amps of electricity through the upper atmosphere, about 65 miles above Earth's surface. To put that in perspective, that's enough electrical current to power hundreds of thousands of homes. The mission will use 3 CubeSats, each about the size of a carry-on suitcase, working together like pearls on a string as they orbit from pole to pole between 260 to 370 miles up. What makes EASY particularly clever is how these satellites will work together. Instead of carrying propulsion systems, they'll use atmospheric drag to maintain their formation, carefully rotating to adjust their spacing so each spacecraft passes over the same region just minutes after the previous one. This will give scientists an unprecedented look at how these electrical currents evolve over time. The satellites will detect these currents by observing microwave emissions from oxygen molecules about 10 miles below the electrojets. The currents create a magnetic fingerprint in these emissions, which EASY's instruments are specifically designed to measure. Each satellite will create detailed maps of the electrojets during every orbit, and combining data from all 3 will reveal how these current systems change and develop. Beyond advancing our understanding of Earth's electrical environment, EASY will help improve our ability to predict space weather events that can affect satellites and power grids. The mission is also engaging students and citizen scientists through the EASY MAG program, distributing magnetometer kits across the United States to allow people to make their own measurements of these vast electrical current systems. The mission is scheduled to operate for 18 months, during which time it will not only help us better understand our own planet's magnetic environment, but also provide insights that could apply to any magnetized planet in our solar system and beyond. This relatively small mission could have big implications for our understanding of how planets interact with space. Next up, just when astronomers thought they had blazars all figured out, one peculiar cosmic object is completely rewriting the rulebook. Lacerte, located about 900 million light-years away in the constellation Lacerte, has been leaving scientists scratching their heads with its unprecedented behavior. Initially mistaken for just another variable star in our galaxy when it was discovered in 1929, Lacerte turned out to be something far more exotic, a powerful active galaxy shooting intense jets of matter toward Earth. These objects, known as blazars, typically fall into neat categories based on their electromagnetic emissions, but Lacerte seems determined to break every classification we throw at it. Recent observations between 2020 and 2023 have shown this cosmic rebel rapidly switching between different blazar types, something that should be impossible according to our current understanding. One moment it appears as what astronomers call an HBL, then suddenly transforms into an LBL, before settling briefly as an IBL, only to change again. It's like watching a cosmic chameleon that can't make up its mind. The X-ray emissions from Lacerte have also reached record-breaking levels during this period. While scientists believe they understand how blazars produce their characteristic double-peaked emission patterns, with electrons and their synchrotron radiation responsible for the lower energy peak, the mechanism behind the rapid switching between types remains a complete mystery. This bizarre behavior has sparked intense debate in the astronomical community. Could Lacerte represent an entirely new class of blazar? Or is there some unknown physical process at work that allows it to change its emission patterns at unprecedented speeds? These questions are keeping theoretical astrophysicists up at night as they struggle to explain what they're seeing. The discovery challenges our fundamental understanding of how these powerful cosmic engines operate and reminds us that the universe still has plenty of surprises in store. As one of the earliest discovered blazars continues to defy explanation, it's clear that we still have much to learn about these fascinating cosmic objects. Let's get an update now from another spacefaring nation. China's space program continues to make impressive strides with their Tiangong Space Station, which has been continuously occupied since its completion in late 2022. The current crew aboard the station, Shenzhou 19, is over 130 days into their 6-month mission and has been conducting groundbreaking research in orbit. The 3-person crew, led by Commander Kai Shuzhe alongside crew members Song Lingdong and Wang Haozi, has been particularly busy with cutting-edge experiments. They've been working extensively with electroencephalogram equipment to study how microgravity affects visual processing and exploring how brainwave music might help astronauts maintain better cognitive control during extended space missions. Wang Haozi, who made history as China's first female flight engineer in space, has been demonstrating the crucial exercise protocols using resistance bands that help combat the muscle and bone loss that naturally occurs in zero gravity. The crew has also been pushing the boundaries of human-machine interaction, working with an AI robot called Xiaohong to develop more intuitive ways for astronauts to communicate with automated systems. Looking ahead, China has ambitious plans for Tiangong in 2025. The space agency CMSA has announced 2 crewed missions, Shenzhou 20 and 21, along with a Tianzhou cargo spacecraft, to keep the station well supplied. In an exciting development for international cooperation, China will also be training Pakistani astronauts for an upcoming short-term mission to Tiangong. This steady progress demonstrates China's growing capabilities in space exploration and their commitment to maintaining a permanent human presence in orbit. As the Shenzhou 19 crew continues their scientific work, they're not just advancing our understanding of space, they're helping pave the way for an increasingly diverse and collaborative future in space exploration. The outer reaches of our solar system might soon become a lot less mysterious, thanks to an exciting collaboration between one of our most distant spacecraft and a powerful new telescope. The Vera Rubin Observatory, set to begin operations later this year, could help chart a new course for NASA's New Horizons spacecraft as it ventures through the Kuiper Belt. New Horizons, which gave us those stunning images of Pluto in 2015, is now about 61 astronomical units from Earth. That's 61 times the distance between Earth and the Sun. While it's still functioning perfectly, it needs new targets to study, and that's where the Vera Rubin Observatory comes in. A team of scientists led by J.J. Cavallars has proposed an innovative survey using the observatory's powerful capabilities. Their plan involves dedicating about 30 hours of telescope time across 6 different nights to conduct what they're calling a deep drilling microsurvey of the spacecraft's trajectory through the Kuiper Belt. This survey could potentially identify around 700 Kuiper Belt objects, and while finding one close enough for a direct flyby might be a long shot, the spacecraft could still make valuable observations of these distant objects. The team expects to discover numerous binary objects, and possibly even contact binaries similar to Arrokoth, which New Horizons famously visited in 2019. The Vera Rubin Observatory's involvement could confirm recent findings, suggesting the Kuiper Belt is more densely populated than our current models predict. If the initial survey proves insufficient for finding suitable flyby targets, the team is already thinking ahead to potentially using the upcoming Roman Observatory to conduct even more detailed searches. This collaboration between Earth-based telescopes and our deep space pioneers represents a fascinating new chapter in our exploration of the solar system's frontier, potentially revealing new secrets about these mysterious outer regions that have remained hidden from view for so long. Well, that's it for today. From the successful launch of Crew 10 to the International Space Station, to the groundbreaking EZE mission studying our auroras, and that fascinating shape-shifting Blazar that's got astronomers scratching their heads. We've also checked in with China's Tiangong Space Station and explored the exciting possibilities for New Horizons in the Kuiper Belt. Thank you for joining me, Anna, on another episode of Astronomy Daily. If you want to stay up to date with all these stories and more, head over to astronomydaily.io, where you can listen to all our episodes and catch up on the latest space and astronomy news. Don't forget to follow us on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube Music, Tumblr, TikTok, and Instagram. Until next time, keep looking up and wondering about the mysteries of our universe.